Hello friends, welcome back. In the previous tutorials we have learned about vectors. A lot of concepts we have learned in vectors like vector addition, vector subtraction, multiplying by a scalar or scaling a vector, finding the distance between two objects, getting the direction vector, so many things, getting how to find out the magnitude of a vector in 2D. Of course 3D is kind of similar. We will understand anyhow step by step. We get a lot of information, guys. Now in this tutorial we are going to understand two most important concepts. They are what is the global coordinate system and what is a local coordinate system, which is really important for us. Now let us start and understand step by step. We are going to understand first global coordinate system. Now global coordinate system is also known as world, W-O-R-L-D, world coordinate system, world coordinate system. Now you can compare this with the real world also. We will compare anyhow. We see step by step. Now global coordinate system is the unity's coordinate system, guys. Now let us get some idea here. The unity has its own coordinate system where the x-axis is a horizontal. You can see that this x-axis or x-plane, you can say, which is a x-axis which is infinite. Now this is x, and you have the y-axis, and you also have the z-axis which is inside the computer. Now this one is x towards right, and you have y upward. Understand this? It's very simple. And you have z inside the computer. So this one is z, which is actually, we say this one is y-axis. Now let us understand step by step. Now unity has this coordinate system where x is right, y is up, and z is inside the computer. And of course it is going to have units here. Let us take this one is of 1 unit, 2 unit, 3 unit, 4 unit, 5 units, and here you have 1 unit, 2 unit, 3 unit, 4 unit, 5 unit. Here you have 1 unit, 2 unit, 3 unit, 4 unit, 5 unit. Of course this side you will be having the -1, -2, -3, -1, -2, -3, -1, -2, -3. Now this is the unity's coordinate system. It is actually, we can say, the left hand coordinate system. Here you can compare this with the real world also. Now I can say unity has three important vectors. We have learnt vectors till now. We know what is a vector. Now unity has three important vectors. In 2D you have two important vectors. In 3D you have three important vectors. Now they are known as, let us understand step by step. There is a vector known as right vector. Now right vector, if you, in 3D also you have a right vector, in 2D also we have a right vector. Right vector indicates the x, right direction, and you have y has a vector known as up vector. Up vector indicates the y-axis, understanding the upward direction, and we have another vector which indicates the z, so that is known as the forward vector. Very simple. Now if you have a 2D, of course there will be only two axes. We will be having x and y axis. So in 2D the right vector is going to have the value x as a 1, y as the value 0. And if it is a 3D, x will be 1, y will be 0, z will be 0. Now these right vector, up vector and a forward vectors are actually unit vectors. That means the vector, the right vector is going to be a unit vector which looks like this. Of course you can see its x value. What is the x value here? 1. What is the y value here? 0. What's the z value here? 0. Simple, right? So it also has another vector, as I told, that is the up vector. So up vector is also a unit vector. It looks something like this. If you go in a 2D vector, then x value will be 0, y value will be 1. If you take a 3D vector, then the x value will be 0, y value will be 1, and z value will be 0. Similarly, you have another vector which is known as the forward vector, which is also a unit vector, guys, and it looks something like this. The unit vector something like this. And if you go get the 2D vectors forward, of course in 2D we will not be having the forward vector. Of course we won't consider the z in 2D, so no forward. In 3D, x is equal to 0, y is equal to 0, z is equal to 1, right? That is what you are going to find. And these vectors are read-only. You cannot change them because they are global vectors, and they always point to the respective axis. They will never change. Understand? If you see the documentation here, if you see, we have a vector 2 structure. There we have the right vector and up vector. You can see here shorthand for writing vector 2 1, 0. The right vector has the value x1, y0. That is what I have explained here. The right vector has the x1, y value 0, right? And up vector has x value 0, y value 1. And you can see in the documentation also the up vector has the x value 0, y value 1. And in our vector 2 structure, still now we have not created the up vector and the right vector. We can create that. Before creating, I just want to show in Unity how it looks and where do you get those two vectors. And they are read-only, they are static properties, and we understand step by step. You can see here they are static variables. Right is a static variable, up is a static variable. And if you want to access the static variables, we are going to use the structure name or the class name, the respective class or respective structure. If you click on the right vector here, you can see it's a static, right? It returns a vector 2. It's a type of vector 2, I can say. Shorthand for writing vector 2 1, 0, that indicates the right vector. And you can go back and see the up vector. It is a static property, vector 2 up. It has the x value 0, y value 1. We can create that. Very simple. It's very easy. And I just also want to show you the vector 3, because in vector 3 you will see vector 3. It's a 3D vector, right? Representation of 3D vectors and points. This structure is used throughout the Unity to pass 3D positions and directions around. It also contains functions for doing common vector operations. Of course, vector 2 also has the common vector operations. Besides the functions listed below, right? It has some other things also that we'll see a little bit later. But here you can see there is a right vector which has x1, y value 0, z value 0. The same thing we have here, x1, y value 0, z value 0. Now you can see there is the up vector, shorthand for writing 0, 1, 0. Of course, we know that the up vector has 0, 1, 0, right? And the forward vector has the x value 0, y value 0, z value 1. And you can see the forward vector here has the x, z, y, 0. And they are also static variables. They actually indicate the global right, up and forward vectors. I hope you guys have understood where do we get what. And we can see, if we want, we can see them. Just I say debug.log. You can say here 2D right vector, RIGST right vector, double quotation, plus vector 2 dot right dot x. I can display whatever the x value is. You can see here the right vector is x equal to, I can say, plus double quotation, then y equal to double quotation plus vector 2 dot right dot y. You can display them. You can access in this way. I'm just showing you the ways how do you access and display them. And even I can show you the up vector. Now we can say 2D, the up vectors x equal to vector 2 dot up dot x. And you can see that one vector 2 is a structure. In that we have a static property known as up vector, and we have the x as well as y values that you can show. Now let us save, and if I run and display, the x should be 1 here, y should be 0, x should be 0 here, y should be 1 here. Let us save and come back to Unity and just run and check. It's processing here, you can say. If I run the code, you should see the right vectors x is 1, y is 0, up vectors x is 0, y is 1. I hope you guys are understanding. It's very simple. And even we can display the 3D vectors. So I can say debug.log. Here I can say in double quotation 3D RIGHT right vector x equals to double quotation plus vector 3. You should use vector 3 dot right dot x. That will give me the x component plus double quotation y equals to double quotation plus vector 3 dot right dot y. Similarly, you have plus double quotation z is equal to double quotation plus space vector 3 dot you have right dot z. So this gives you the z value. You can see that. And also I would like to show you here that in vector 2 dot forward, we don't have a forward, we have right, we have up vectors. And you can see also vector 2 dot right. If you see, it's a static property, so we are using the structure name and they are getters. You cannot set the values for them. They are global, they indicate the global coordinate systems up, right and forward. So now I can also display the up and forward vectors x, y, z values. So here we write up, here I write up, here I write up, and here we write forward. Forward vector we see FORWARD, forward. Here I say forward, and here I say forward. And these are all, you should remember that they are global coordinate vectors. They are global coordinate vectors, right up and forward. Let us save and come back to Unity. Let us run and check. You can see here that 3D right vectors x is 1. The same thing we have here, x is 1. Y is 0, same thing we have, y is 0, z is 0. Then 3D up vectors x is 0, you can see x is 0, y is 1, you can see y is 1, z is 0, of course z is 0. And forward vectors x is 0, y is 0, z is. These vectors we use a lot of times in games to move the game objects with respect to the global coordinate system, with respect to the world coordinate system, you can say. Right? We move the game objects in the world only. So we are going to use these vectors, and you should remember that they are unit vectors, and you should remember what are the x, y and z values in 2D and 3D, because it's really useful, guys. I hope you guys have understood where do you get these coordinate systems, and of course you understood what are their values. Now what we do, we are going to understand the local coordinate system so that you get a clear idea what is the local coordinate system. Now let us take, you create some game object and bring that in your scene. You place somewhere in the world. Let us take, you want to place some game object in the 3D world at x is equal to 2. Let us take x is equal to 2, y is equal to 2 and z is equal to 2. You want to place some game object at x2, y2 and z2. So x is 1 here, 2 is here, y is 1, 2, z is 1, 2. So the game object will be over here. Now, with respect to the world coordinate system or a global coordinate system, you have placed your game object over here. Now, at present, your game object is at 2, 2, 2, right? Simple. So, that is the position vector, you can say. The position vector of your game object is going to look something like this, right guys? It looks something like this. So, that's your position vector of your game object with values 2, 2, 2. And you can say it is going to be somewhere over here, your 3D world. Simple, right? Now, when you bring any game object, every game object is going to have its own local coordinate system. Understanding? So that is known as local coordinate system. Let us understand that local coordinate. It is also known as self-coordinate system, we can say. Self-coordinate system. Now self-coordinate system we understand here. Let us take your game object is something like this. The game object is something like this. Now this game object is at present, you can say, at 2, 2, 2, and it is going to have its own coordinate system as I told. So here it is going to have the right vector, it is going to have the x-axis, you can say, it is going to have the y-axis itself, it is also going to have the z-axis which is looking inside the system. Understand this step by step. This indicates the right, this indicates the up, and this indicates the forward. If it is a 2D, you will be having only right and up. Now these vectors. These vectors, the right vector and the up vector and the forward vector, they are actually unit vectors. Again, same, they are unit vectors. Now this is the local coordinate system where you will be having the x-axis, you will be having the y-axis and z-axis, and the game objects are going to have the right vector, up vector and the forward vectors. They are unit vectors. They are with respect to the local axis. So try to understand, please. It's most important, my friends. Now here, this one is 1 unit, this one is 1 unit, this one is 1 unit. That you should remember. Now let us understand what is the difference between local and the global. The global coordinate system will never change. It will be always same. Understanding? Whereas the local coordinate system is going to change of the game object, specific game object, depending on its rotation. When you create a game object, by default, the right vector you have here, R-I-G-S-T, right vector you have the up vector, its up vector you have, okay, and you also have its z vector, that is actually the forward vector, F-O-R-W-A-R-D, the forward vector. Here, by default, when you create, the right vector's x value will be 1, y value will be 0 if it is a 2D vector. If it is a 3D, then the right vector's x will be 1, y will be 0, z will be 0. You can see both are same. Here, the up vector is going to have x0, y1 if it is a 2D. If it is the 3D, then x will be 0, y will be 1, z will be 0. Then if the forward vectors, x will be, we won't consider here 2D, so only 3D we consider 0, 0, 1, that's a forward vector. That is how it looks in the beginning when you create by default. Now let us take, if you rotate this game object about z-axis or around its forward vector, you can say, if you have rotated this game object by 90 degree, then how it looks? You can say very easily that it looks like this, right? It rotates by 90 degree. If it has rotated by 90 degree around forward or a z vector here, its local coordinate is going to change. Its local coordinate system is also going to rotate. That means you are going to have your right vector up and you are going to have up vector to the left. Of course, z vector or the forward vector will be same as it is inside. Understand this. It's an important concept, friends. It's not difficult to understand. So this is how it looks, guys. Now, if you see the right vector is over here, R-I-G-S-T, looking upward actually. The right vector's x value will be 1, x value will be 0, y value will be 1 if it is 2D. If it is 3D, x will be 0, y will be 1, z will be 0. It has rotated, my friends. And similarly, the up vector. The up vector is now has the value. That means here the up vectors and the local coordinates, right, forward and up, are going to change. They are not just read only. They are modified. So up vectors x will be now, it is going to be -1. The y will be 0. Similarly, if it is a 3D, then definitely the x will be -1, y will be 0, z will be 0. And the forward vector is going to be same. It will not change because you are rotating around forward vector. So forward, the forward vector x will be 0, y will be 0, z will be 1, guys. Are you understanding? So based on the rotation, now your local coordinate system has got changed, whereas global coordinate system will never change, it will be always same. Now local coordinate system and global coordinate system, understanding these two concepts is really important. Why? Because while moving your game object, while rotating your game objects, we will consider these two important systems, whether we have to rotate around local coordinate systems or whether we have to use the global coordinate system to rotate or move the game object in the world. Now you can compare this with the real world. Let us take an example that, let us take here, usually the north is upward, then right, this is south, this is north, this is south, this one is the west, and this one is the east. If you can, this is, let us take the world, right? The world has north, east, south, west, and let us take you are standing over here and looking towards north, and you will be having your own coordinate system. For you, this is the forward. For the world, this one is up. Let us take, for this one is up, this one is right, and this one is down, and this one is left. Now let us take, you are standing over here, right? If you are looking in this direction, right, for you, let us take, you are looking in this direction, you're standing here and you are looking in this direction. Of course, for you, this one is north, right? According to you, north is front, and this is down, same as it is. This is east, or you can say this one is right and this one is the left for you, correct only. But if you rotate and if you start seeing this side, if you rotate, if you take a left turn at exactly 90 degree, and if you start looking in this side, actually for you, this one is north, right? And this one is right, this one is left, and this one is down, right guys? But the world coordinate system will not change. North is north, west is west, south is south, east is west, east is east, right? For global, you can say up is up, right is right, left is left, down is down. But for you now, the north, with respect to you, the north is this side, down is this side, or you can say up is this side, down is this side. If you see with respect to global, then this one is west for you, this one is east for you, or you can say this one is left for you, this one is right for you. So you people need to clarify these doubts. If you have doubt, please clarify this now only, because they are very, very important. I hope I have explained in a clear way without any doubts. So I hope you guys have understood. Don't worry guys if you have not much clear idea, because I will be giving lot of examples step by step to make you understand these things very clear. How do we use the world and local coordinate system for movement and the rotation of the game objects? I'll be giving you different examples so that you will get a clear idea of how you can use them in your Unity games or simulations. I think for this tutorial, this much is enough guys. So keep learning, keep coding, keep sharing, and of course in the next tutorial we are going to see with an example so that you get a clear idea. So thank you guys, thank you very much. See you in the next tutorial. Keep learning, keep coding, keep sharing.